Good morning, everybody. I hope you're all having an awesome day. This is Giddy Physicist, and today I want to talk to you about my 2022 Chainlink Hackathon project, which is called AdMM, the Adaptive Market Maker. And so to start off with, I just wanted to mention a lot of these ideas are based on a really cool paper that I just read a couple weeks ago. So this is the paper on Archive by Mike Wu and Will McTeague. So constant power root market makers. So the basic idea is that in the traditional automated market makers like Uniswap or Curve, Uniswap being famous for the XY equals constant trading function, and Curve having a more complex one, but that is very linear around a long region, which gives you more capital efficiency for the for trading between stable coins. And so the basic idea is that in these markets, the shape of these curves is fixed, and there's nothing you can do about that. Now, as you trade, the reserves change according to the function here, and then as fees accumulate, the curve moves outwards. But the basic idea, and one of the ideas that they mentioned in the paper, is that you can generalize this and have a trading function that's defined by a single parameter called Q, which is just a number, and then the X and Y values here are the amounts of tokens X and Y that you're going to be swapping, and then K is just a constant. And so the interesting idea is that as Q moves towards different values, it approximates some of these curves differently. So as Q approaches 1, then you have just X plus Y equals a constant. That's your constant sum trading function, which would be a perfectly linear curve. Now, if Q approaches 0, then you have to take some limits, but essentially that simplifies to the XY equals a constant case. And then as Q approaches -1, you start to get curves that have more curvature. And so here the dotted line is something Q value of 0, and then the orange and the green, orange and blue as you're moving outwards, have more curvature, and then the green one out here has less curvature. So the basic idea is that what if we had a set of trading functions that were adaptable, so that for a given history of prices of tokens, you could adapt the shape of the trading curves to give the most optimal value both for liquidity providers and for traders. And so that was the idea that I wanted to prototype in this project. And so this shows just a few different examples of changing that Q parameter and what it would look like. So this happens if you change Q at a certain point in time, you want the reserves to stay the same. And so if the reserves were at this location and you start to tune Q, then it changes the slope, which changes the price. But then you can use that to adaptively change and approach the best solution, both for traders and liquidity providers. All right, and so on here, I wanted to talk about the contracts that I deployed. If you want to check that repo, I put it under this link here. The front end is also under this repo, but I also built an interactive app for it. And so we can jump to that in just a minute. Or actually, let's just do that now. So here's the front end to the dApp. And so this interacts under the hood with the contract that I deployed to the Rinkeby network. And so the basic idea here is you can update the Q value. And so here you can display the exchange data. So if I click that, it has some default values for token X and token Y reserves, and then a Q value of -0.5. So what we're going to do here is we're going to try and update the Q value. We'll switch it to 0, say. So that'll make it an XY equals a constant. Hit update Q. That brings up MetaMask, which lets me run this function. If it'll let me confirm. There we go. And then we've just got to wait for it to finish. As we wait, I can sort of talk to this a little bit. So that should update only this Q value here. So what that's doing is for a, there we go. So for a given curve here, which now we have equal reserves, that means we really are sitting like at this point right here. We went from negative 0.5, which had more curvature, so it's probably something like the blue curve, and then went to q equals 0, which is like the dotted curve. And so now that that went through, I can hit display exchange data, and you can see that the q value updated. And so, so now what happens if we want to make a swap? Well, here we can choose which of the tokens we're going to swap, choose the amount, which just throw something in and hit swap. Brings this up. And so just to note that this is not actually doing ERC20 token swapping. This is just it's doing the same math on the reserves, but this is just a prototype case. And so we can wait for that to trade. All right. And then look at the exchange data. And yep, so we traded something. Now if we go to something that has a lot more curvature, I'm going to go ahead and update that Q value. Oops. Oops, I actually did 2 of those. All right, let me hit update Q just to do 1. Oh my goodness. Sorry, guys. All right, confirm that. And then while that's working, I'm going to go ahead and switch this to token Y, and we'll go ahead and say we're going to trade in 1,000, and then see how this does. All right, so check the exchange data. All right, Q is now at -1, and if we swap, this time swapping in token Y, and again, this particular case doesn't have any fees associated with it, just for the prototype. So now we're going to trade in 1,000 of token Y and see what happens. All right, so that went through. Oh, and now we have different values for token X and token Y. And so the values that you end up getting depend on the curvature of the function that you're dealing with. And so, so that is about it. If you have any questions, feel free to reach out. There's a few things that we have looking forward. I think that the basic contract works. And so just adding in a few more details, getting some of the functions working for the different Q values is an interesting challenge. Doing some of the root powers is going to be challenging, especially using integer math. But I think that's something we can figure out. This shows essentially how you would interface it and how to make it a essentially autonomous machine learning built and adaptive filter, where over time you use Chainlink keepers to look at the price volatility data. And then as a function of the price volatility, you'd have some target value for M. And then however much your current trading curves are departing from that M gives you a delta. And then you use that to update the curve to approach what would give both traders and the liquidity providers the best value. And I think I'm running up on time. So thank you so much. I hope you enjoyed this, and hope you have a great day. Thank you.